Yes.
All right. Good morning, everyone. I am Professor Raimundo Alberto Portillos from the School of Architecture at the University of Monterrey, Mexico. Today, I am presenting my work entitled Virtual Reality is a Gamification Strategy in the Architecture Classroom. This is a part of a research project that began in 2022 and is still ongoing, in which together with my student, we are testing new immersive technology applied to design in the spatial learning. VR is a technology geared toward spatial immersion. The operator is introduced into a virtual environment in which they can move, interact, and explore various multimedia content, image, videos, or sound, through movement, voice, button, and specific gestures. The virtual experience is considered immersive because the subject is isolated from their context and immersed in a simulated view of a space through the use of electronic device, lens, and gloves, which allow them to interact with the digital form and element project in the simulation, creating the sensation of being in the place, even though it don't physically exist. If architects deal with the design and habitability space, VR prioritizes the principle of moving around and exploring a place that does not exist. It simulates space. This is where is the greatest contribution and promising future for the design lead is a new virtual space need to be explored and designed for the professional architecture. The beginning of the technology are linking to the recreational activity is the first experiment arose in the context of video games. However, VR is new use in the professional sphere and specifically in design of various scales, urban, architectural, industrial, and interior design. On the other hand, gamification is a pedagogical strategy applied in the classroom for the learning through play. It seeks to generate through techniques that are fun for a student, new experience and lectures that are more meaningful and valuable for the grade process. It applies in various areas of teaching, from basic to the university levels, adapting to the educational cycles and model. As a result, it's a big gaining ground in the pedagogical discussion of new generation. Currently, many gamification strategies are associated with the use of information and communication technology, as electronic devices are a familiar medium for a student at school age. We arrive with a new and challenging expectation for learning. Therefore, the aim is to motivate the curiosity and creativity of the participants. So is the case with architecture, whose primary pedagogical function is to emphasize creative thinking as a strategy for design training. It's a professional practice. It requires skills and abilities that encompass perception, spatial perception, architectural drawing, and learning digital tools, among others. Gamification in the architecture classroom is therefore a strategy for exploration, learning by doing, designing by creating, solving creativity through playful exercise, and incorporating digital tools in the design process is a fundamental part of contemporary architecture. This work fits precisely into the design thinking, incorporating VR in the classroom for pedagogical purpose, using gamification as a teaching strategy mediated by spatial virtuality, simulation, and digital modeling. To this end, the study applied a statistical model to evaluate playful experience VR in architecture learning. In terms of methodology, the study has the following overall objective to evaluate the VR gamification experience in architecture students using the GAMEX tool. GAMEX stands for Gameful Experience in Gamification, is an instrument that measures learning experience in educational environment. The tool is mainly used in English and German-speaking contexts. For this occasion, GAMEX was adapted to Spanish using the translation by Parra and Segura. The GAMEX instrument presents 6 dimensions: enjoyment fun, absorption, creative thinking, activation, absence of a negative effect, mastery. Using a quantitative approach, the study validated the VR experience of 51 students from the School of Architecture at the University of Monterrey in Mexico, from the second semester architectural representation course. The sampling was not probabilistic, circumstantial, with the students who took the course between 2023 and 2025. The dimension of the GAMEX instrument were rated on a Likert scale from 1 to 5. The questionnaire consists of 27 items and one administered in Spanish to the entire population. MetaQuest 2 class were used, allowing immersion and manipulation of objects with hand controllers. The modeling software was Archeo. Students could design, set the scene, render their work, and review in the cloud from laptops. Let's look at some examples of the work. The classroom and his model. The data were analyzed using descriptive, statistic, and organization based on the calculation of mean per student, per item, and per dimension. At the same time, standard deviation were estimated and using 95% confidence intervals. The dimensions were compared with each other, also applying a student test for pilot, bilateral, sampling in order to verify whether the differences were observed. The results are presented below. The first approach was through analysis of the means of average weighting by dissension. In terms of assessment level, the dimension with the highest means were enjoyment fun and absorption in green. This indicates the student perceived the VR experience possibly is a playful strategy that promotes motivation and idea generation. The rest of the dimension, activation, mastery, and creative thinking, were at the intermediate level, reflecting and favorable experience, but not as high as the previous one, in yellow. The lowest dimension was the absence of negative effect, showing that not all students experience the same degree of comfort. These data are shown in the graph on the screen. This result is understandable because students really enjoy when they offer a different educational experience. In most cases, it was the first time they had working with VR and entered in immersive environment designed for learning, not just for play games. That is very important. This is why the experience had a great impact. They not just use VR, they design in VR, but linking that they were study the analysis and spatial understanding of architectural objects, and the combination of novelty and academic relevance is precisely what explains why the dimension of enjoyment, creative thinking, and absorption appear so high. To deepen the analysis, the standard deviation SD of each dimension was calculated in order to determine why consistent student response were and whether the rating were homogeneous, widely dispersed. The SD graph was also organized in 3 levels. First, low SD, very homogeneous response, high consensus. Second, medium SD, moderate variation, clear trend in yellow. Third, high heterogeneous groups, divided or polarized experience. Applying this criterion, we observe that the dimension with the highest mean, enjoyment, and absorption also have a low or moderate SD, which means that it was not just a few enthusiastic students, but rather that the positive assessment was widely shared by the student. In contrast, the absence of a negative effect, shown the highest SD above 1 in red, indicate that not everyone experienced the activity in the same way. Hence, the point of interest in paying attention to the disparity in this result. The percent confidence interval, CI, was also calculated for all dimensions, show the range which the reasonable to deem to the true population mean size of the same instrument is applied to similar groups. The percent CI is obtained by considering the observed mean, the standard deviation, and the critical value of the t-distribution according to the sample size. In practical terms for this study, narrow CI is enjoyment and absorption, indicate accurate estimate and therefore consistent result among students. Wider CIs, as in absence of a negative effect, confirm what the SD already showed. This is more heterogeneous in the response. Students did not experience that dimension in the same way. This helped to justify in the discussion the gamification VR works well to motivate an activity creativity, but that I need to be refined in terms of comfort, timing, and familiarization with the equipment. In the graph, it's important to observe the CI spread, whether wide or narrow, to identify where there is a greater dispersion and therefore where student perception were less homogeneous. Although the disparity in data between the highest and lowest dimension was already known, a more in-depth analysis allowed for the following summary. First, enjoyment and creative thinking have a high mean with narrow CIs. This indicates that the VR gamification experience was positive and above all consistent among most students. Second, the absence of a negative effect shows a low mean and wider CI, greater variability. Some students experience discomfort, fatigue, or difficulty with the equipment or timing. This statistical pattern suggests that some aspects for the experience need to be adjusted. The item by item analysis showered by the item 20 belonging to the dimension of absence of negative effect was the one with the most disparate response of the entire instrument, with percentage distributed across the several options on this scale. This behavior helps explain the high SD of the dimension and the wider CI and the subjects that the VR experience. And true values motivate is still conditioned by implementation factor. This result is maybe due to several factors: the timing and the schedule for the practical session, with some students found inflexible or too long for a single immersive session, the ergonomics of the equipment, which is still heavy, and can cause physical fatigue after several minutes or continued use, usability of the software, as for many, it was the first time they had used for design purpose, and not just for play in VR. They design in VR, which implies a learning curve. It and the complexity of the task, designing and modeling a three-dimensional architectural object with limited information and playful format can be challenging, especially considering the level of training of the participant in first semesters. In order to verify what the different observed were attributable to chance, student t-test filed bilateral, samples were applied comparing the highest rate dimension, enjoyment, with the lowest rated dimension, absence of negative effect. In all cases, the observed t-value were well above the critical value, therefore there are a statistical significant difference between the positive dimension and the negative effect dimension. The graphical representation of the t-distribution allows us to visualize that the dust difference are clearly outside the no-rejection zone, reinforcing the idea that no pattern form is not random in this study. Overall, the result allows us to affirm the gamified VR is highly effective in activating enjoyment and creative thinking, but that it requires adjustment in instructional design, familiarization with the equipment, and session duration to reduce negative effects and thereby narrow the dispersion observed in that dimension. The study confirms the hypothesis that VR is a useful tool for gamification in architectural learning, as it motivates and engages students in understanding the solution of form and space in an intuitive and creative way. Therefore, the research demonstrated the existence of clear strength. Gamified VR strongly simulate imagination and ideation, and do so consistently and relatively uniformly in students who are learning architectural design process. However, weakness associated with experience and the tools, and we also identify which are reflected in the dimension of absence or negative effect. Consider that the weakest point of the study is at the present a low mean and the large dispersion. This suggests the presence of factors linking to frustration, discomfort, diseases, or overload in some students. The most important implication is in the design process, VR shows high potential for enhancing creativity, but is not guaranteed comfort or full adaptation of all student for the immersive environment it's on. Therefore, the quality of the experience must consider not only the use of equipment or application times, but also aspects of ergonomics, rig, periodic familiarization session, and instructional design in the classroom, which help to regulate the perceived negative effect. In addition, the study confirmed the statistical analysis process to validate the gamification and VR experience in the classroom, which can be replicated in other studies with the application of the GAMEX instrument. In short, virtuality remains a frontier to be explored from the perspective of architecture and challenging several of the tangible foundations of materiality and spatial movement. However, this immersive experience allows us to approach a space that don't not physically exist, but can be explored, perceived, and understood, opening up a field of multiple possibilities for school, teachers, and architecture professionals. We operate in context of constant technological adoption. Thank you very much for your attention. Here's the link for my new book, From CAD to AI, the Digital Transition to Architecture in Open Access, in Spanish.